So today we are going to be working with adding and subtracting positive rational numbers. Now, that sounds kind of fancy, but really all it means, positive numbers, you will learn about negative numbers in 6th grade. So for you, everything that you know number-wise is positive. And rational numbers really is just whole numbers, decimals, and fractions. Okay, now we haven't done fractions yet. In fact, we're going to start doing those tomorrow. Okay, but we have done whole numbers and decimals. And the reason that we're doing this is a spiral review, meaning we've already done it. Okay, we have already covered this teak many times. Okay, we did it for whole numbers and we did it for decimals. However, this is one of those teaks that on the first CA we did not do well on and that we need to practice. Okay, so there's two parts of this teak that are really important, and that is the algorithm. Okay, the algorithm really just means how you get your answer. Okay, how do you add? How do you subtract? That actual strategy, that process. And then the word problems. Guys, this is super important. You need to know how to break down word problems, which is why I keep putting in almost every single day short little videos that show you how to break down a word problem. Some of you are watching them and some of you are not. Guys, these both work together. Okay, you cannot be successful with this particular teak if you don't know how to do both. I can teach you how to add or subtract whole numbers and decimals, but if you can't look at a word problem and break it down and figure out that that's what you're supposed to do, then it doesn't matter. And vice versa. I can teach you how to break it down from the word problem, but if you don't know how to actually add and subtract, then it doesn't help you. You must have both of these things in order to be successful for this teak. So that being said, we're going to do a couple of algorithm problems, okay? And then there will be a word problem that we'll break down, and then we will work on some word problems together as a group. So first I have 1,003,586, and I want to add 89,783. So I see that that's a whole number, both of them. The important part about adding whole numbers is to make sure that I have the same place values lined up. So this goes to the million spot, but this is only the 10,000 spot. This right here is the 10,000 spot. Okay, so I can't write them like this. This is a common mistake. Okay, that doesn't work. I don't have my place values lined up, and I can see that because of these commas. That does not look right, does it? Okay, so I have to make sure that I am lining up the numbers by their place value. Okay, if not, then I'm not going to get my right answer because then I am adding different place values. So I'm going to make sure that the 8 is in the 10,000. If I have to, I can count over. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. That means the 8 must go here. Okay, and then I can write out the rest of the problem like this. Okay, so now I'm going to add them together. 6 plus 3 is 9. 8 plus 8 is 16. I write down my 6 and I regroup my group of 10. 5 plus 7 is 12. Plus 1 is 13. I write down my 3 and I regroup that group of 10. 3 plus 9 is 12. Plus 1 is 13. I write down my 3 and I regroup my 1. 0 plus 8 is 8. Plus 1 is 9. There's nothing to add here, so that is a 0 as a placeholder. And then we have a 1. All right, so now what I want to do is I want to estimate to make sure that I have a reasonable answer. Okay, so I'm going to change to a different color. And over here, I am going to, since this was the 10,000ths, That is the highest place they have in common. Okay, that would be here and here. I'm going to round to the 10,000ths. Excuse me, I keep saying THS. That's not correct because remember THS is for decimal. I'm going to round to the 10,000ths place. Okay, so if I'm looking here, this is a 0, and if I go next door, that is less than a 5. So that means that this 0 is going to stay the same. Okay, so remember everything before that is the same. Everything after that is a 0. So then this would be 1, 0, 0. That's the place. So then 1, 2, 3, 4 more zeros. This is 1 million. Okay. Now for this one, I look next door. That is 5 or more. So that means that this 8 goes to a 9. And everything after that becomes a 0. So this is going to round to 90,000. Okay, if I add them together, 0, 0, 0, 0, 9, 0, 1. So that's 1,090,000. Well, look at this. Our sum was 1,093,369. Okay, that's actually pretty close. We're only about 3,000 off. And when we're in the millions, 3,000 is pretty close. Okay, so this would be a reasonable answer based off of just our estimate. Now we want to go backwards. Okay, what I mean by that is we are going to take the same numbers, 1,093,369, that was our sum. And now I'm going to subtract 89,783. If we did this correctly, I should come up with this answer right here. Okay, so I'm going to take my 89,783. 9 minus 3 is 6. 6 minus 8 I cannot do, so I have to regroup. Going next door, I'm going to change this to a 2. So I'm trading for 10. 16 minus 8 is 8. I cannot do 2 minus 7. So I'm going to regroup from here and add a 10. 12 minus 7 is 5. I cannot do 2 minus 9. So I regroup. And now I have 12. 12 minus 9 is 3. 8 minus 8 is 0. And then I have a 0 and I have a 1. 1,003,586. 1,003,586. So now I've estimated to see if it was reasonable, and I've performed the opposite operation, which tells me that this is the correct answer. So that's just a quick review for whole numbers. Next, we're going to talk about this decimal that we see up here. All right, so it's kind of the same ideas as the whole numbers when I'm adding and subtracting decimals. So over here, since these two whole numbers were different place values, I had to be really careful with how I lined up my numbers. Same thing with adding and subtracting decimals. The number one reason why students get adding and subtracting decimals wrong is because they are lining up their decimals incorrectly. So I see that this is 1 789 thousandths. And this is 3 2/10. This 7 is in the tenths place, okay? And the 2 is in the tenths place. So I need to make sure that those are on top of each other, okay? I can do this when I write this out if I just focus on the decimal, okay? So the decimals have to be lined up. So for this, there's a 3 on the left of the decimal, and there's a 2 on the right of the decimal. Okay, so lining up that decimal is very important. Then for these places that have nothing, remember I can add a 0 after that 2/10. I could add zeros forever. And as long as it's just a 0 and not any other digit, I'm not changing the value of this number. Okay? So once I have zeros in this place, then I can just add just like we did with whole numbers. Okay, 9 plus 0, 9. 8 plus 0, 8. 7 plus 2, 9. 1 plus 3, 4. Making sure that I write down that decimal. Okay, so I'm going to do the same thing that we did over here, and we're going to estimate to check for reasonableness. Okay, since both of these have whole numbers, I'm going to round to the nearest whole number. Okay, so if I'm looking at the ones place and next door there is a 7 that is greater than 5. So I would say that this rounds up to 2. If I'm looking here, I have a 3 and I go next door and that digit is less than 5. So this number rounds to 3. Well, 2 plus 3 is 5. So my answer that I got was 4 and 989 thousandths. Is that close to 5? Absolutely, because if I rounded this whole number, okay, and I look next door, that's greater than a 4, this actually rounds to a 5. Okay, so I know that this is a reasonable answer. But now I want to do like we did over here, and I'm going to double check with the opposite operation. So I'm going to start with 4 and 989 thousandths. And I'm going to subtract, this time, 3 and 2/10. Okay, again, making sure that I line up that decimal. Okay, it's a 3 on the left and a 2 on the right. Okay, just like we did here, I'm going to add some zeros as placeholders. And now I subtract. 9 minus 0 is 9. 8 minus 0 is 8. 9 minus 2 is 7. And 4 minus 3 is 1. Placing my decimal point. That is what I started with. So based off of my estimate and off of my inverse operation, we did this question correctly. So this covers a quick review of the algorithm. So next we're going to look at breaking down a word problem. So this is a question that was on your CA, okay, that fits this TEK. It says Mia's grandmother lives 208 miles east of Mia's house. Mia's aunt lives 564 miles west of Mia's house. What is the distance from Mia's grandmother's house to Mia's aunt's house? Okay, I can do this a couple of ways. I can draw myself a picture. Okay, I can say that this is Mia's house right here. Okay, and I can say east. Okay, east normally on a map is this way. So Mia's grandmother's house is east 208 miles. Okay, her aunt's house is west 564 miles. And they're asking how much in between them. Okay, so looking at that picture, I'm guessing that I probably need to add. But I want to do my totals and labels. These are the things I talk to you about in most of your word problem breakdown videos. Okay, so remember for totals, I'm looking to see, do I know my total? Or am I trying to find my total? Well, this is asking me, hey, what's this distance? I don't know that total right now. Okay, that's what I need to find. So if I need to find a total, my options are to add or to multiply. Okay, next as I look at my labels, remember those labels are, we always have numbers, but the labels tell us what the number means. Okay, so 208 what? Miles. 564 what? miles. Okay, so both of those are the same labels. Okay, if they're the same labels, I can add or subtract. Okay, so I can see that both of these have addition. So just like I saw with my picture, I've now proved to myself that I need to add. So I'm going to add 564 plus 208. 4 plus 8 is 12. 1 plus 6 is 7. And 5 plus 2 is 7. Now, that was not a very tricky problem at all. Okay? What's tricky about this is that then we have our griddable. Okay? So this is super important on a griddable. Be sure to use the correct place value. Ladies and gentlemen, if I write the answer like this, which is the way most people that get this wrong write this answer, I am saying that between Aunt's house and Grandma's house is only 7 72/100ths of a mile. Okay? But really, it's over 700, almost 800 miles. This is not a reasonable answer. Okay? So if I'm looking at that 772, is that a decimal or a whole number? Okay? It is only a whole number. Okay? If it's a whole number, I do not use these columns. Okay? These columns stay blank because there is no decimal. So I would write my answer in this way. And then, of course, when I'm actually taking a paper test, which honestly I don't remember from the electronic test, you may have actually had to do this on the electronic test too, but I know for sure on a paper test you need to color in those numbers. Okay? Also, because there is no decimal over here, these stay completely blank. Okay? We do not put zeros in a griddable for any items that don't have a digit in that place. You just leave it blank. So that has been a quick review of the 5.3K teak.